Okay, well, welcome everyone. Before we start the session, I would like to acknowledge the traditional owners of the land, the people of the Kulin Nations on whose land Monash University operates, as well as paying our respects to their elders, past and present. As this session is being run as a webinar, I will ask that if you do have a question, please submit it through the Q&A button on the bottom of the screen. The questions will be visible to the panelists and the hosts, and we'll monitor that the chat throughout the session, and we'll answer them towards the end. So welcome everybody. It's great to have you all join our session today, the first session of the Choose Your Own Adventure series, where we'll be providing you with a real-world insight into numerous and varied ways that leading practitioners use and deliver technology solutions to create value. We're very excited to have Philip from Amazon, Ollie from Paddy's Foods, and the Master of AI Course Director, Shuri Pan here. Thank you for taking the time to support the series. I'll just have a brief introduction with Philip from Amazon. Philip started out as a linguist in Germany and the UK, but switched to machine learning during his PhD. He graduated with a PhD in natural language processing from the University of Amsterdam. During his last year in PhD, he interned with Amazon in Berlin and got offered a position as an applied scientist as a result. He started working in machine translation team, now part of AWS Translate. Due to his interest in probabilistic modeling and approximate inference, Philip switched teams to work in a small group providing probabilistic modeling solutions to businesses across Amazon. Philip moved to Australia last year and is now working with Anton van der Hengel's group, which helps provide Amazon teams in India, Japan, and the US. Ollie from Paddy Foods is a technically orientated client director that specializes in overseeing and leading teams in the development and integration of advanced data solutions into business ecosystems. Ollie is passionate about data and analytics at a business level and often advises stakeholders and executives in data strategy, maintaining relationships with clients across multiple industries. Originally starting his journey as a data scientist, Ollie takes a holistic approach to his advisory work and project leadership by bridging the gap between technical experts and business stakeholders. So thank you all. Thank you both for joining us, giving us an insight, giving our students an insight about what it's like once we leave our nest egg of Monash University. So Philip, maybe I'll start with you, if that's okay. If I can ask you a few questions. Firstly, what is it like to work in this field?
Right. In the field, it's exciting, I would say, first of all, because there are just so many things to do. Working at Amazon specifically, I think we always describe Amazon as peculiar, right? And one thing that's peculiar about Amazon is customer obsession, right? So you're really working for the customer and you're trying to invent on behalf of the customer.
Yeah.
And there are just so many problems across the different businesses that Amazon operates in that you can work on, that literally from computer vision, natural language processing, optimization, supply chain management, et cetera, et cetera. There's like a whole range of topics to cover. So that's exciting. And I think what's special about it, if you compare to, like, say, pure research, is that you have this connection to the customer, right? Where the customer may literally be the consumer purchasing stuff on the Amazon website. It may be an AWS client, or it may be an internal team that's looking for a solution. And the nice thing is you're building a model and you're evaluating it with your standard evaluation metrics, right? That you would use for writing a paper. But eventually you actually see the impact on the customer, be it through an A/B test, be it through direct customer feedback. Also, when your model gets launched, right, you can actually track its performance over a longer period of time. And that's really exciting, actually.
Yeah, absolutely. And what would you say would be the biggest challenges and opportunities in this space?
So big challenges, opportunities are literally everywhere. Like, one thing is, for example, Amazon has committed to going carbon neutral, right? And with just the supply chain that's in place, and that's a big challenge. Obviously, intelligent interaction, like conversational assistance, that is huge, like thinking about Alexa. Other things are robotics. So most of the fulfillment centers have now robots installed that pick the item that you have chosen, pick it from the shelf, start packaging it, that kind of stuff. So yeah, I would say big challenges really in all realms. Yeah, and if you want to focus on something, it would be, I guess, NLP, computer vision, robotics, and then that kind of operational research and optimization.
Yeah. So besides the technical aspect of it, what type of, say, soft skills would a student require or a grad require getting into the field?
Right. So I mentioned customer obsession before, right? And it's one of our leadership principles. So in total, we have 16 leadership principles, customer obsession being one of them. Another one that I find quite interesting myself is earn trust. So you're not just working for yourself, right? You're going to be working in a team, and you're going to succeed as a team. You might also fail as a team, right? And in order to build relationships with other teams, in order to build relationships with customers, I think earning trust is essential. And part of earning trust is communication. So when I talk to other scientists, we'll talk about the intricate details of a model, or we may talk about a particular evaluation score. But when I talk to like stakeholders, which may be product managers who don't have a technical background necessarily, I need to communicate in a way that is accessible to them and that is understandable to them. So yeah, the soft skill that's really important is communication. Another soft skill, again, relating to one of the leadership principles, is have backbone, disagree, and commit. So you need to be comfortable to call out others, and you need to be comfortable to voice your own opinion. We actually encourage people to voice their own opinion and to make themselves feel heard. But it's disagree and commit, right? So also if you are having an idea and the team decides to go another route, you then need to say, okay, it is what it is. Yeah. I'm still going to be committed to the project, and I'm going to keep working on it.
You'll need to be a team player. Yeah.
Exactly. So yeah, communication on all levels, be it with stakeholders, customers, and also within your own team, I think is essential.
Absolutely. Thank you. And is there any kind of other skills that you'd recommend students to focus on while developing at uni?
Yeah, so presentation skills. And presentation skills really from ranging from giving a presentation to writing papers. Coding is essential. Yeah, I think those are like the, if you want, harder skills or the more scientific skills, like presenting your work and then also coding it up and being efficient at coding, right?
Sure. This is a bit of a different type of question, but what career changes have you observed in the industry from a recruitment perspective as technology has evolved?
Right. I mean, one big one is deep learning, right? These days, everybody does deep learning. So deep learning is definitely a big one.
Yeah.
Another thing is just demand. Like if you look back, so I started in 2018 at Amazon, and I interned in 2017 actually. And even back then, the demand for machine learning scientists, data scientists was quite large, but it's just exploded since then, right? Like if you look across the entire industry, pretty much any company you can think of at the moment has a demand for some kind of analytics. Many companies set up their own data science, machine learning departments. So yeah, I think just the demand of the skills and the versatility of the skills that's changed dramatically.
Sure. And so what type of tips do you think you could recommend for students on how to narrow down their interest in, say, MI or machine learning to choose a career path?
Honestly, don't narrow them down too much. So especially if you're going to be a PhD student, as a PhD student, you're already quite focused, right?
Yeah.
And you have to understand that the particular skill that you may have may not at this point in time be useful to your employer. Like it may be a great skill, but the particular problem or the particular project you're going to focus on may need other skills, right? So try to broaden your horizons. You don't need to be an expert in everything, right? It's good to have your one area of expertise, but at the same time, try to branch out and try to broaden your horizon. I think that would be my advice.
Perfect. That's great advice. Looking back, is there anything that you would have done differently prior to beginning your career or even during your career?
Yeah, I would have taken a bird's eye view earlier on. So I used to, like in the first year, I would say I used to be really bogged down in my own code and my own problems, or the problems I was working on, and not care very much about what my team was doing or what we were even doing in a bigger context. And it's interesting, first of all. It's interesting to know what the business is actually doing and what the greater context is that you're operating in. But it also helps you understand what you're doing yourself, and it helps you prioritize your tasks. So certainly looking at the bigger picture is something that I would have done much earlier.
Yeah. Although I guess when you're starting, it may often be a bit hard to see the full picture when you're getting in there, correct?
So, it is hard, and that's just ask. Like,
yeah.
Don't be shy. Go out and ask. Ask your colleagues, ask your stakeholders.
Yeah. Is there? I know that some organizations have a rule where there's no dumb questions, correct? Like the more questions you ask is actually more beneficial for both the students or the graduate as well as the company, right?
Certainly. And I think one thing that often goes a bit unnoticed are like these water cooler conversations, which unfortunately, due to the COVID situation of the past years, haven't really happened. But just grabbing coffee with someone can be extremely illuminating and can, bring out a lot of details about the problems they're working on.
Sure, that's great. Okay, we hear a lot about future-proofing your career and the skills needed to do that. In your opinion, what are the necessary skills students should, you've touched on the soft skills, but is there any other type of skills that me as a university student should look to try and achieve?
Yeah, kind of circling back to like an earlier question. You already mentioned the soft skills, so I think communication is a big one.
Yeah.
Broadening your horizon, right? You never know where things are going to go. Like, have you been working on neural networks in 2008, 2010? People wouldn't have taken you seriously, and now that's the big hype, right? So, yeah, definitely staying broad. Try to stay on top of like your field of expertise. I think that would be a good one. Yeah, just try to look out for trends, try to recognize trends.
Yeah.
And of course, another thing I've said before, coding. So you need to be able to code.
Yeah. More of a personal question. What tech innovation are you most excited about in your field?
That would be causal inference. So I'm personally working on causal inference, and I think there's just such a huge potential for that kind of technology. First of all, from a legal perspective, so in the EU, for example, you now need to be able to justify your algorithm's decision, or you need to be able to track how your algorithm came to a particular decision. So it's actually a legal requirement. But I think also for companies themselves to gain insights into their processes, especially if these processes go wrong, right? You want to know what the root cause is. And I think causal inference is extremely exciting. It's, in a grand scheme of things, I think rather underexplored. So there's also a lot of research work to do in that area.
Sure, lovely. And what's one question you would have asked earlier in your career?
Why are we doing this?
Why?
Again, coming back to like, I used to be totally bogged down, right? And first of all, you lose track. Mm-hmm. That's not good. So you should always ask, why do you want me to do this task? Why should I be working on this particular problem? So for your own state of information, I think it's good, but also to challenge leadership, right? So your manager or your professor at uni may tell you to do a certain thing. It's fair to ask why they think that's a good idea. And sometimes when you ask them why they think it's a good idea, maybe you come up with a better proposal, right? You can actually initiate a discussion that way. And I think that's important for like the success of a team.
Yeah, absolutely. That's a great point. And just finally, what's one piece of advice you would like to leave our students with?
Don't be shy. So, and don't be shy in two respects. So one thing that you touched upon when you start in a company, especially as an intern, it can be quite daunting. So, but don't be shy. Everybody's actually super friendly, right? And everybody is very willing to help you. So just ask your questions, right? And reach out to team members when you need help. Don't waste time trying to figure out everything by yourself. Everybody has gone through that process before you. Right. So people are super happy to help.
Yeah.
So I think that's one aspect of not being shy, just asking people around you. The other aspect of not being shy, just apply. Like sometimes I think people have this feeling that, again, the application process can be daunting. Just do it. I think there shouldn't be like this mental barrier. Just put yourself out there and present yourself and get better doing that.
Lovely. Great advice. Thank you so much. Thank you so much, Philip. They were the questions I had for you today. Appreciate your time. I know there may be some questions coming through.
There's actually one in there specifically pointed to Philip from Xiao Yu Sun.
Okay, yes. I have a question for Philip. I'm super interested in AI, especially NLP. I've learned machine learning on course, and I am a transfer student from mechatronics engineering to computer science. I'm wondering, when you applied for PhD, did you have a published paper during your undergraduate? And could you give me some advice on undergraduates who are interested in AI?
Sure. So first of all, like, to my personal history, I did not publish as an undergrad. I did publish as a PhD, and I did my internship later in my PhD, in the last year of my PhD, which is something I would generally advise, right? Because then you have a better overview of your field of research and you kind of know your way around better. So yeah, last year of your PhD is probably a good time to apply for an internship, or second to last year you apply and then you do it in the last year. General advice for an undergrad who's interested in AI. So I come from linguistics, right? I didn't actually have a background in computer science or machine learning. What's helped me a lot is mathematics. Just really try to brush up your math skills. And then a lot of these things, like, let's talk about something simple like linear regression, right? You can learn about linear regression as a way of, fitting a line through a point cloud, or you can just think of it as a matrix problem, right? Having this mathy background helps you a lot to, like, generalize machine learning concepts.
Perfect. Thank you for that. Let's see if there's any other direct questions for you. Okay, I've got another question here. What are some things I should be doing to gain experience in order to apply for positions like internships? Whenever I look at offering or post, I feel intimidated by it and what they require from your CV. Like, I think you did briefly touch on that previously, where we should put ourselves out there and get rid of that fear. But is there any other kind of tips that you can give our students when they're looking to apply for that internship or grad role?
Yeah. Okay. So a couple of things, right? So a lot of companies have information out there. Actually, if you look at Amazon.science, you actually get a better idea of, like, the kind of problems that we're working on. That's one tip. So familiarize yourself with what the problems are that you're working on, or that you might be working on. The second tip would be to really utilize your recruiter. So you're going to be assigned a recruiter who's going to be handling your application process. I'm just asking what's expected, right? And they'll be very happy to help you. You'll usually get, not usually, you'll always get an email specifying what kind of questions we're going to ask and, like, how you can prepare. So there's actually a lot of preparation material that's going to be sent your way when you apply. And if you don't find that sufficient, the recruiter is there to help you. So just reach out to the recruiter and ask them to provide more information.
Perfect. That's a great answer. Thank you so much. Well, I think they were the only ones that we had for you, but that's fine. We will, if any further questions come around, we can circle back. But now, Ali, if I could have a quick chat with you again, just some fire chat questions for you. But if you want to give us just a brief kind of outline of your history, I think you've got something in common with a few of the students in here from this university.
Sure. Yeah, I'll keep it fairly brief because it's not the interesting parts to talk about. I started in computer science and had no idea I was going to go into data when I first did that. I thought I was going to be a software engineer or something like that. But by sheer luck coming out of computer science, I ended up my first role being in PwC in their data analytics team. So through that, I learned to enjoy data science in general, picked up a lot of the skills I needed, and then continued my career from there. I've spent the vast majority of my time, the last, what would it be? Oh goodness, I'm getting old, 7 years now, working in consulting. So I've worked in upwards of maybe 30 or so different businesses in both Melbourne and wider areas around the world, including the United States. And more recently, I've started working in Paddy's Foods for the last, what would be 8 months or so as their head of analytics, while I still do some consulting on the side as well. That's the general background for you.
Lovely. No, I appreciate that. Again, I just wanted to run through some quick questions with you. First, what is it like to work in your field?
If you're talking about consulting in general, it's pretty good if you can handle fast-paced work. That's probably the best word to describe it. It differentiates it from regular kind of work.
Sure.
It's just a bit fast-paced. So if you're working in consulting, you're very often thrown into ongoing projects or things that are already happening, and therefore the pace of what's going on around you tends to be quite quick already. Alongside that, usually there are timeframes around what you need to be doing, which further exacerbate that time friendliness that ends up going on. But if you're comfortable working in sort of high-paced environments like that, you won't have any difficulty working in consulting. And there can be all different kinds of people and types of work that happen in consulting itself. Consulting is just a blanket term for you coming in essentially as a side contractor of some kind to either advise upon something or do work in that space. And very often I see consultants who do no real talking whatsoever and sometimes just work on very hard problems, whereas there are other people who do no actual practical work and are entirely advisory as well. So it's a very, very broad field.
So I guess if it was to come to students who may have a few issues speaking or presenting, that there is scope as for them to do their consulting. I guess.
Yes, absolutely. So there are actually, I would argue there are almost two different kinds of data science that get applied generally around the place. I don't know what I would call these, but I'll describe them to you. One of them is where you're working very much as an engineer of sorts. So often a job role for this would have the word engineer in the title. You might be a machine learning engineer, for example. This is very similar to a software engineering role in that your role there is to create models or do something specific in terms of coding as far as machine learning and data science goes. On the other hand, there's a class of work for machine learning and data science. It's a bit more advisory, even if you are not a consultant. So you might be in a business, but you might be doing everything from helping them set up a business intelligence to running ad hoc analyses over their data sets, anything like that. And it's very communicative as far as the work goes. The engineering side can also be very communicative. And I would generally suggest that soft skills are a boon in any role you have in a business. But if you really, really hate talking, yes, there are roles for you out there. It is totally fine. Yeah. Just be aware of that. And I will say, actually, this is just advice in general, but it does very specifically apply to machine learning and data science. Confidence is something you must have in this line of work, but confidence is not necessarily what you think it is. Confidence is not being able to get in front of a crowd and talk about whatever topic it is for an hour. It's not being able to push someone out of a conversation and speak the loudest in the room. True confidence and self-confidence is just being comfortable with yourself. And that's really all you need. That's the main thing. Comfortability with what you can and can't do. Comfortability that you can approach a problem, even if you don't know how to solve it immediately, and give yourself the time to figure out how it's done. And it's comfortability knowing what your limitations are as well. If you have two people in front of you and you say, okay, I want you to get up in front of a crowd of 100 people and give a presentation on this topic. And one person puts their hand up and says, yep, I'm more than happy to do that. Just tell me what it's about and I'll make sure I'm prepared for it. Then yeah, that sounds pretty confident to me as well. But similarly, if the other person says, hey, I'm comfortable with the topic, but I'm actually really not very good at public speaking, and I think it would be best if someone else went up there and did that, and they just clearly say that, that is confidence. That is a really hard part of confidence to actually achieve. It's self-confidence, knowing what your own limitations are and what you're comfortable with. If you do not like getting up in front of a crowd of people and talking, that's cool. You're not technically required to do that ever. You can just say no.
Yeah.
It's some people might be disappointed depending on what's going on, but you're your own person. You can do whatever you want. So be comfortable with yourself and don't be afraid to assert your position on things. That's the main thing. Be comfortable saying to people, no, I'm not comfortable with that. That's really all it is. If you have that level of self-confidence, you're going to go very, very far when it comes to data science. And this is the reason why. So I'm talking for a long time on this topic.
No, not at all.
The key reason you want to do that is because your role as a data scientist is not just to create models or do fancy things with data and numbers. It's also to help other people interpret that information as well. As much as you might create a really fancy model that's easy to interpret and has numbers that come out at the end that are super easy to apply in a situation. Like maybe you've created a model that can help a business identify new customers or something like that. Might be very easy to understand what that model does, but there are intricacies that go on with the numbers and data that only you will probably understand. There'll be things in the model that you need to be aware of, like, okay, it's not very good against this class of person. Or maybe you can interpret the high numbers really well, but the lower ones are a bit more difficult to work with. Whatever it happens to be, there will be caveats in everything you do. And people around you will constantly misinterpret what they need to do with your numbers just because it's not their field, not because they're dumb, not because they don't know what they're doing, but because a person who's spent 20 years being the executive of a business and making big, fancy business-wide decisions just doesn't know how a model works typically. And that's not a failing on their part, it's just not their role. That's actually your role. Yeah. Your role is to help them know how they should be interpreting those numbers. And that means you need to be comfortable saying no to a person's face. If someone says to you, oh, I'm going to do this with your model, and you know that's a bad idea, you need to tell them, sorry, the model's actually not quite for that, it's more for this. Or yes, you can do that, but here's a caveat around how you'll need to be using it there. Yeah. That confidence and that comfortability is very important. But again, it doesn't mean you need to be comfortable doing a lot of social interaction. It's just that assertiveness you need to have and comfortability as a person.
Sure.
Hopefully that answers your question, which I've forgotten what actually was at this point.
No, you definitely did. Again, okay, so within your role, both with Paddy's and your consultancy role, what have been the biggest challenges and what are the opportunities in your space?
I'll come back to challenges in a second because it's a bit of a broad topic, but opportunities are more or less everywhere. Philip mentioned this before, the industry is wide open at the moment.
Yeah.
And there are a few bits around that are quite interesting. So one is that there's very high demand for people with good data science skills. Exactly what constitutes good data science skills is a bit up in the air at the moment. And the reason that is because there are currently very few, if any, standards for data science, which is something Philip did offhandedly mention before as well. Individual businesses and individual people themselves will have standards around what they do as far as data science goes, but there are no actual real worldwide or even nationwide standards for how you should approach these things. If you look at something like software engineering as an example, there are standards all over the place. You can pick and choose in some case widely accepted standards about how you should structure your code, how you should comment it, how you should set up your entire environment, so on. There are a lot of standards around what you can and can't do, and you can choose to follow those standards or not, but they exist. Data science has very few of those, and the ones that do exist are typically not widely accepted, though you can of course choose to use them. And that also goes for the types of skills you need. There are some simple bits of advice you can give in terms of skills, like, yeah, having maths is really helpful if you can brush up on your maths.
Yeah.
If you can code already, that's a big boon because coding is a part of a lot of machine learning and data science. If you're going to learn a programming language, Python is a really good one to start with because most places use that as their data science-y language. But those will all still vary depending on where you go. And at the end of the day, none of this is particularly well standardized. So that's not necessarily a bad thing. It does mean you can approach it at your own pace and really try and figure out what kind of niche you can fill. Because the industry is so wide open at the moment, and there's a huge demand for data scientists in general, probably whatever you choose to specialize in or you like the most will have openings for you. If you go, well, I like data science and machine learning, but while I was learning that, I actually found I really enjoyed the part where I get to present results to people and make presentations and make visualizations and graphs and charts. If you really like that kind of thing, you can just lean into that. And that can be a huge part of your role in any business because that kind of thing is in demand. If you want to go hardcore into the machine learning and maths and science and just sit around making AI that will eventually take over the world, there's probably a role for you somewhere as well. It's all open at the moment, which is a really good thing, but it can be a bit difficult to initially choose where to go, which is the caveat to that.
Yeah, absolutely. We discussed soft skills previously. Was there anything other, I guess, negotiating, communicating, these things are massive for our students to pick up on and learn. Well, you got the lamb playing some games. But obviously, team harmony, I guess, would be one of the biggest things, seeing as though these last 2 years, we've all been working online, working with people from across the world that we ordinarily wouldn't have had the chance to. So what are some skills just off the top of your head that you look for in a graduate or you would like in your team?
Yep. So other than the self-confidence and comfortability I mentioned earlier, this one's going to be slightly wordy to explain. Humility, but quite specifically what I mean by humility. To be humble when you're doing something like data science is actually a very practical skill for what you're doing. There's a lot of ego that goes on in tech skills in general. So if you go to any place that does software engineering or works in very high level tech area, you're going to get a lot of egos going around. Some people will feel like they are God's gift to computing and they're amazing. and that's fine as long as they've got other good qualities that help them be a good team member. There are going to be some people that think they're super smart, but maybe they're a bit all over the place. But there's a lot of ego going around, right? And that can be fine. And it's not necessarily a bad thing to have a degree of ego in the work you do. Data science, there is a very severe detraction from being ego-driven. And this is, in my opinion, one of the biggest barriers to what makes a good data scientist and what makes a poor data scientist. There are so many ways to interpret numbers that come out of models, or not even models, just maths. Any given number you're working with isn't just a number. It represents something in the real world. And the context of what that number means is critically important. But there are many different ways to interpret that number and what it actually means. And you can present that number in a number of different ways. You've probably all heard that saying where you can say anything in analytics, essentially. You can make a number look like anything. You can dress it up as whatever you want. That's not because people are liars or because there's some cheat code in analytics. That's because there are genuinely multiple ways to interpret information most of the time. A good example of this is sunscreen. And if anyone's seen me talk before, they'll have heard me talk about sunscreen because I love it as my first example here. SPF 15 versus 30 sunscreen. SPF 15 blocks 93% of the sun. SPF 30 blocks 97%. So 93 versus 97%. If you go, all right, present that information to someone, what could you do? You could subtract 93 from 97 and say, well, it's a 4% difference. Doesn't sound very big. But if you reverse it instead say, okay, well, how much sun does that let through? The 97% lets through 3%, and the 93% lets through 7%. So we're comparing 7 and 3. And you could say, well, 7 is 2.3 times bigger than 3. So technically speaking, SPF 15 sunscreen lets through more than twice as much sun onto your skin when you're out in the sun, which is very relevant if you're outside for, say, 10 hours. But those two numbers I just gave you, 4% and 333%, that would be as a number. 4% sounds very different to 333%. And which one you choose to tell someone will dramatically change how they interpret that information. But the annoying thing about it is they're both right. If someone said it's a 4% difference, I can't say that's wrong. And neither if they said 333% difference. They are both correct. They are just different interpretations of the same data, and they're looked at from a different perspective. That is one of my best examples I've got of how the way you interpret your information can dramatically change the conclusions you draw from any given analysis. Now, the reason I mention that in terms of humility is because what that means is whenever you come up with something in data science, whether it's a conclusion or just a number that you want to show someone or something that just leads into more analysis that you're doing, the very, very, very first thing any good data scientist should do, and you should do if you're listening to this, is question whether you're interpreting it the best way. Not the right way, because there's typically no such thing when it comes to working with numbers, but the best way. Are you looking at this number from the right direction? Have you made some assumptions you shouldn't have made? 9 times out of 10, I find that my first assumption on a piece of work in terms of the outcome tends to be incorrect. I've interpreted a way that maybe not incorrect, but it's not the one I actually ultimately go with. So I'll get a number out of an analysis and go, oh, cool, I have a feeling it's going to be presented this way. But then when I dive into it further and look around and maybe get more numbers to support it, I suddenly realize I want to angle it a different way. So it's not about being right and wrong. It's about choosing the best way to present the information for what you're trying to do and the audience you're actually working with as well. So weirdly enough, humility is actually an incredibly important skill when it comes to working in data science, because interpretation is everything. I forgot what your original question was, so
no, that's all good. That was just what a student should focus on. So I guess a bit of humility, some smart.
Yeah, I'll keep a shorter answer for the rest of that. In terms of what to focus on as far as generally soft skills go, I recall you mentioned, it's the same as any job you'll ever have ever. Any soft skills you can pick up are good. Try to be a bit humble, try to be more assertive. Anything you can do to help yourself practice explaining things is going to come in a huge amount of handy, because you'll have to explain stuff a lot to people. That can be as simple as talking to your uni friends and just practicing explaining a topic. One of my favorite exercises for that is you might pick a friend or a group of friends and you all agree with each other. You're going to go online and find a data sciencey project or white paper or article or something and learn about it and then explain it back to them a week later. So you all go away, you pick an article or something that you're interested in, pick something you're interested in, that's very important, otherwise you're not going to do it. Read about it, and then a week later, all get together and just take turns presenting back to each other. Ideally pick different things so you don't end up cheating by accident. and just practice speaking back. Then you all make a pact with each other. You're going to be honest and give good feedback to each other and say, your presentation was bad because of this, or I didn't quite explain this bit because you missed this part, something like that. Just get that practice in. You might not be very good at it to begin with, but eventually you'll become more comfortable. And that's a skill that will really be of huge value to you almost in any kind of work you end up in, but particularly machine learning and data science.
That's great. Thank you so much. What career changes have you observed in the industry from a recruitment perspective as technology has evolved?
As I said before, there are those two different types of machine learning and data science work. That was a huge shift in the industry. So as few as 5 years ago, the concept of a data scientist was so broad and undefined that recruiters would just be looking around saying, we want a data scientist, we want a machine learning person, or something like that, and not strictly have much in the array of requirements beyond that. And a business might be looking typically just for someone to come in and just be good at that kind of thing and kind of be a bit of a self-starter. Whereas now you still have that kind of thing going on, but now there are a huge number of specifically defined roles in this space as well. This is the biggest shift I've seen, other than technologies and that kind of thing. That's things like machine learning ops, MLOps, or however you want to pronounce it. That's a term that's popped up in the last sort of year or two. Yeah. Things like specifically types of machine learning, so things like tree-based modeling versus things like neural networks. Those are differentiated now in the industry, and a business will typically be looking for one or the other, or in some cases both. There are machine learning engineers who are more designed around integrating their code into other things, which can sometimes fall under MLOps or other different roles as well. Data science has now been broken down into a whole bunch of different fields, which includes things like business intelligence. So if someone says they're a data scientist, but they predominantly work in business intelligence, don't laugh at them. That's legitimate. It's not machine learning, but it's still a discipline in data science. And it's equally as important from my perspective. So the categorization of these things has been quite significant, and it does help in some ways in terms of what you should be looking at. If any of these speak to you, or there's something you're particularly interested in, it's now easier to type in search terms for what you want to do. As Philip mentioned before, if you are not quite 100% sure where you want to go into this or exactly where to start, try and keep your options open. Just genuinely look at whatever's interesting to you. If you're not sure yet, just go, oh, well, I liked the sound of making an AI. Just Google AI articles. I just literally type in AI into Google. There's probably a few things that'll pop up that might be interesting to you. Follow a news aggregator. So I've just posted this as an answer earlier in one of the questions that popped up. If you're interested in data science as a broad whole topic, but you're not sure where in that you're interested in, there's a news aggregator I use called Data Science Central. So you just sign up for that. It's entirely free. And every week you're just on a mailing list to receive new white papers, articles, talks that people are doing, that kind of thing. And they're across all different areas of data science. And if any of those pop up that you're interested in, jump into them. And if it's not interesting to you, that's fine. Don't read it. Just start wherever you're actually interested, because that'll give you the motivation to keep reading into it further. And what you will eventually find is there's something that really speaks to you and you want to go and jump into it.
Yeah, perfect.
And Philip, if you want to jump here at any point, because I'm talking a lot here, but we don't, I know you said a lot of things that are actually mirroring a lot of this earlier. So if you've got something to jump in, just do it.
I guess we can have an open discussion later on.
Yeah.
Yeah, absolutely. So I guess looking back on your career, is there anything that you would have done differently, Ollie?
That's a loaded question.
It is.
With the benefit of hindsight, yeah. I mean, if I knew all the things that I know now, but generally speaking, not really. And I think this is what most people will say in any of their careers, generally speaking. As long as you're the kind of person who does jump into new things and isn't afraid to take a chance on things, especially when you're young, when you've got a bit more of the backup to do that. Taking those opportunities is the most important thing. If something pops up and you go, oh, I'm kind of interested in that, should I go do that?
Yeah.
If you really think it's of interest to you, seriously consider doing it. And it's not as big of a deal as it sounds to kind of jump between a few different roles when you're starting out in this kind of thing. As long as you do that kind of thing, you're not going to have very many regrets, because while it may not work out, at least you were doing essentially everything a human being can do to get the best outcome. And that feels good. Even if it hasn't quite worked out, it feels good to know that you did the right thing, which was take chances on these things and try to get into something that actually interested you as well.
Perfect. And any tech that's interesting you or intriguing you, that's currently?
One of my favorite things I've read about that unfortunately I've not had much experience with is generative adversarial networks. So it's a type of AI neural network type thing where you pit essentially two AIs against each other in order to help the learning process for one of them. So as an example of this, and this is one of the first and most interesting applications it's been applied to, there's a thing called image inpainting, which is where you take an image and cut pieces out of it or have parts of an image that are obscured, and you get an AI to try and fill in the blanks on that image. So you might cut a square out of an image, or there might be one that's blurry or has a thing in front of an object, something like that. You ask an AI to fill in the blanks. A really, really, really complicated problem, and people in general can't do this unless you're a really good artist. To train AI to do this, and it's been shockingly effective as well, you can create two different AI. One of them, its role is to make the fake image, and it starts essentially at ground zero, not being good at drawing anything. And you get a second AI, and its entire job is to try and mess up the other AI. Its job is to say, I've caught you, you're a fake image. Or say, no, as far as I can tell, this is an entirely real image. And you get the first AI to train against the second AI. So the first AI is constantly trying to improve its image filling in skills, and it starts off terrible at this. The second AI is constantly trying to get better and better at picking and finding out whether it's actually been a fake image or not that's been filled in. And what you find is both of them get very, very good at this. It's more complicated than this, just to be clear. But eventually each of these gets very, very good at doing this. And eventually it gets to a point where the AI, the one that's meant to figure out whether the image is fake or not, can't even do it. The image is so flawless that it can't determine that it's a fake or not. And the other image, well, it's trained its whole life to get to that point. It's now good at filling in the blanks on the image such that another AI cannot actually figure out whether it's been faked or not. So you can apply it to more different things. It's very commonly applied to things like games as well. So not all game engines, but some of the really big game AI that are up. God, the names are escaping me at the moment. The ones that have played things like StarCraft and a few others, some of those are generative adversarial networks. They fight against themselves over time to improve. Things like that. It's a very, very fascinating area for me, but unfortunately I do no work in it.
Yeah, that's so good. And just finally, what's one piece of advice that you'd like to leave our students with here?
Just start doing things. I know it's a really simple piece of advice, but I see a few questions in the chat, which we should actually get to in a second. Some of the questions are things like, where do I get started on learning a new thing, or anything like that? What should I start reading? What should I study? That kind of thing. If you really don't know, just jump onto Google and do something. Start reading anything. Again, what I mentioned before, you'll eventually start finding something you're interested in. Even if you just heard a term in a movie and you thought it was cool, Google that. See if there's an actual real world application for it. Because a lot of things that happen in sci-fi as far as data go are actually based on real life things that happen. Or maybe just coincidentally, there's a real life thing that does it. Anything that interests you at all, just jump into that and start doing it. The biggest barrier to entry in most things, not just data science, is getting started. There was a really good question in here about how to get started on and setting up your own project portfolio. Almost, 30 minutes ago that one got posted. If you want to make a portfolio, genuinely just get started. And the cool thing about a portfolio is it's whatever you want it to be. The important thing is just that you're able to talk through it. You can have one thing on your portfolio, and that's totally fine as long as you can talk to someone about what it is and the ins and outs of it. If it's something you made, great, you can talk about your process for making it. If it's something someone else made and you're just doing a case study on it, that's cool. Be prepared to talk about it. It can only be one thing, and you can still get a really good amount of value out of having your own portfolio. But if you're the kind of person who wants to put a lot of mini projects in there, just little things like, oh, I made a small tool that does this, and oh, I did a tiny analysis on this, that's fine too. Just be prepared to talk about it. Just get started. Figure out something you want to chuck in there and do it. Barrier to entry is doing it at all. That's my piece of advice.
Perfect. Thank you. That's great.
You should ask Philip and Shirley as well. It's a good question. I don't think I got the name of it.
Well, that's a good lead on, I guess. We got Shuri here, the Master of AI course director. If we may have some undergraduates in here looking to get into the AI space. Can you tell us a little bit about what the Master of AI entails and what benefits they can get from studying at Monash?
Okay, thank you. So actually, on Monash have the Master of AI course, and I think it's quite a new one. And in this Master of AI course, we cover a broad of AI topics from different perspectives, including the optimization, for instance, and also we cover the NLP techniques. We also cover the image processing, and so all these are different subtopics of AI. So, for instance, when students enroll in this course and they are very interested in NLP, then they will further focus on NLP, and then we are designing new units and which will cover the advanced topic of NLP, including the machine translation field just mentioned. So and also if you are more interested in the, for instance, in the computer vision, we also have this kind of units such as image processing, so that you can spend more time on this kind of topic, and also optimization. So basically, when we talk about AI, basically there are different components in real life or in applied projects. We have data. We will have a lot of data, and then we will develop some AI algorithms based on different type of data. For the text data, we will use the NLP techniques, NLP algorithm. For an image, so we will have a computer vision. And also there are a lot of optimization problems there. For instance, if you like to travel from your home to the airport, so a lot of rules there. So what is the best rule to direct you to the your home, from your home to airport? So a lot of problems, and our course will cover almost every aspect of AI. So, but at the very beginning, so for instance, some students are coming from different background, from business, finance. Actually, we in the first semester we will have some basic and foundation units which can set you up. For instance, we have the program unit, the Python programming, and also Java programming, and we also have the mathematical units for data science and AI, so that you can build your foundation in the first semester. And then in the second semester we will gradually lead you to the advanced AI units. And then in the second year, you will have some kind of the industry experience projects, or you can do a research master. You can do a research topic. So with a lot of AI experts at Monash University. So this research topic is worth for, I think, 4 units. So it's 24 points, so you can spend the whole year with a supervisor to further develop it. Yes,
that's great. So we do, within the course, you do have the industry experience option, or being able to do a minor thesis, which is a great, I guess, foot in the door if you're, I guess, interested in continuing with a PhD like Philip. So that's really good. We could just quickly look at these questions to see if there's anything that...
A few of them have repeated the question of hard skills.
Yeah.
So not soft skills, but hard skills.
Hard skills. Philip or Ollie, would you like to take an answer of that one, please?
Yeah, I can start if you don't mind. So hard skills, coding. I mean, if you want to be an engineer, then definitely coding. If you want to be a scientist, then it's coding plus one area of expertise in machine learning. So where you have a really deep understanding and you can basically hang with someone who's got a expertise in the area and like just have a conversation, right? So it's not about like, making you feel uncomfortable or whatever, but just have a conversation with someone and show that you really thought hard about this and that you have a deep understanding. Yes, I think these would be, and then breadth, right? So breadth is also important, what I mentioned before, right? Where you just have a good overview over what's out there, in particular when it comes to problem solving, right? Because as Ollie mentioned, like for any given problem, there are hundreds of solutions. There isn't necessarily a right solution, but what you need to be able to do is you need to be able to reason about solutions, compare solutions, and then once you make a decision for a solution, justify that decision.
Thank you.
Very completely. I'll get more specific into that, just in terms of specific things to start with, if you're not sure where to begin. Everything Philip said was bang on. That's the kind of stuff you want to look at. If you're really struggling to know where to begin and you just don't know what to get started with, there are 2 no-brainers that every good data scientist should have a good understanding of, to a degree at least. One of them, obviously coding. If you're going to get started and you don't know where, Python is probably the best language to begin with. Main reasons being, one, it's currently the most popular general data science tool. Two is it's fairly easy as far as programming languages go to start learning. And three, it's got a lot of community support. Being that it's so popular, there are a lot of answers on Stack Overflow about how to do things. Python's a good coding language to start with. Just start doing some basic tutorials. Don't necessarily begin with a data science focused one. In terms of maths, very, very important to have a good understanding of maths, but that importance will vary greatly depending on which area of data science you're into. If you're doing deep learning, maths is super important. They start doing things like derivatives and lots of funky stuff. Whereas if you're going into something more like visualization, the maths is a bit less heavy, but some understanding of maths is important. And the particular area of maths you probably want to focus on is statistics. Now, to be clear, I don't expect any of you to go and just become experts in statistics overnight and start reading a bunch of statistic papers. You'll fall asleep multiple times in the attempt. But what you should do is learn the fundamentals of statistics. This is things like really basically what are some of the calculations you have to do in statistics. Don't memorize them, just do them a couple of times. Things like, how do I determine the correlation between variable A and B? You can get a list of what the basics are, just online, Google it. But things like, what's a correlation? How do I calculate it? What is the significance of an average versus like a mean versus a median? What's the mode? What's the standard deviation? That kind of thing. Get those basics just so you know what they mean. And the last one is understand the core concepts. So in looking at those basics, understand not just how to do them or how to interpret them, but what they actually mean. What is a standard deviation? Shockingly, few people can answer this question, even those that sometimes work in data science. What does it mean? Why would you ever want to look at a standard deviation? What's a normal distribution? Normal distribution is the bell curve. Why? Who invented that? What's it for? Why do we use it? Why do we talk about it? The why is the most important thing. I'll give you a cheat on the normal deviation, normal distribution. The reason we look at those and the reason we use those is because they're everywhere. Normal distributions pop up in so many different areas in the real world just by accident. It's just a really common thing that happens. And so we call it a normal distribution, and now we do things to it, and we have a lot of concepts that are around normal distributions. Get that why so you can talk about it, and also so you know where you're going next if you want to dive into these topics further. Just the basics. Don't try and dive into advanced statistics. You will fall asleep. It's hard. Just the basics.
Yeah.
So that and Python, that's my two pieces of advice in terms of where to get started.
There was a question, I'll just follow up on that, Ollie. Is experience of a software engineer necessary for being a data scientist?
No, as Philip himself can attest to. He's mentioned before he came from a completely different background from coding. I forgot what that background was. What was it, Philip?
Linguistics.
Linguistics, there you go. That's got no coding in it as far as I'm aware. Although if you're going into natural language processing, maybe that's some benefit there. I know people who've come from physics, statistics, maths, computer science, linguistics now, that's a new one. All sorts of strange areas. Some of them make sense, like maths, some of them are a bit more left of field. The key thing is making sure you do the time to learn these things, whether that's on your own, trying to pick up the new coding skills or whatever it happens to be, or sometimes learning from your co-workers. You might be in a workplace that has data scientists that you can talk to. Other alternatives is, I'll just rattle off a couple of things you could do, and these will all depend on the specific situation you're in. You might be working not in the data science space currently, but maybe people do data science in your business. Just tell your manager that you are interested in it and ask if you can do a tiny, teensy little bit of it here and there. Can you talk to those engineers? Is it okay if maybe you've got some of the skills? Can you help them out for a day and see what happens? Can you just get thrown into the deep end? Just ask. People are surprisingly flexible. I know it seems like there are a lot of rules everywhere, but people run the show. People are everywhere, and they're the ones that actually do everything. So if you just ask the right person, very often you can end up shifting a little bit into this stuff. And that goes for asking someone like Philip or myself or Shirley, anyone you want to hook up with on LinkedIn or just talk to in the real world. Just ask. Ask what they should be looking at. Ask for help on something. See if you can get a coffee with someone. It's the best way to get into this kind of thing. And just keep being inquisitive like that. Even joining this webinar is a good move. Talking to someone like Philip, for example, if you want to get into the engineering side and you like the idea of working in a place like Amazon, well, here you are. You've heard from Philip, which is obviously awesome to do. So you're doing the right thing just by joining a thing like this.
Yeah, I mean, all the students in here have already taken the first foot forward, so that's great. And like Philip said, put yourself out there and let people know. Otherwise, they'll have no idea, and you'll be sitting there overthinking when the opportunity is there to chat.
I think just following up on what Ollie said, right? There's no expectation, especially when you come straight out of uni or it's your first job. There's no expectation that you're perfect, right? I mean, even after 20 years, you're still not going to be perfect anyway, but there's no expectation that you know everything. I can just speak for myself. I have become a dramatically better programmer, like in the 4 years at Amazon by my own standards. And there are programmers out here that are still vastly better than I am now, right? So the room for improvement is infinite. So don't expect that you're going to be like the best programmer or the best data scientist when you start out, because nobody's expecting that of you.
That's a great point. That's a great point. Philip, there was another question directed for you. It says, I'm extremely interested in the area of AI and data governance, policy and legislation. Philip mentioned that there's now legal requirements for explaining the predictions made by your model. How developed is this field / conversation of governance, and what are the job opportunities in this area? Is there something that is more managed by the company's principals or the developers themselves?
Yeah, that's actually managed by the company's lawyers. So because so first of all, I should say, as far as I'm aware, that's Europe, right? I don't know what the situation is in Australia. And this legislation came out, and I think it's still very much developing, right? So I think there's both a question about how to police it and then also how to implement it. And generally, again, I mentioned before that's interesting to see different sides of the business. I haven't worked in that space, by the way, so right, it's not something that I have personal experience with. But there are company lawyers that will help you making these judgments, right? Because you're not a legal expert, you can't, right? So they can give you advice, and then based upon that advice, you can act and you can structure your code a particular way. You can make decisions as to choosing model A over model B because model A is more explainable, that kind of stuff, right? So it's, I think, a very nascent field. And yeah, I think everybody's just trying to figure it out at the moment.
Okay, brilliant. Love that. Were there any other questions? There were a few that have come through. Just quickly, I'm just browsing because there's some that I can help out with, but I'm seeing if there's any that Ollie and Philip can answer directly. Yeah, I think a lot of these have been touched on. Look,
I'll just jump in here, KJ.
Yeah,
I've noticed there's a lot of people asking about, is it to get into sort of the AI or data science, is it best coming from a computer science background or a software engineering background? We've partially answered that question. I think we have a few undergraduates either in a software engineering degree or a computer science degree. So anyone sort of, I think we can answer a few questions if we can just have someone address that question.
Is that specifically in terms of transitioning into or getting into it initially?
Yes, correct, yes.
I've spotted a bit of that question around as well. Things like, is computer science or software engineering a good way to get started, that kind of thing. Yeah, it is. You can come from a linguistics background like Philip did, but obviously it's going to be easier if you happen to have some of the skills already. So if you've gone from computer science, you've got a little less of a stepping stone to get into data science, because coding underpins a lot of the actual physical work you need to do. If you come from a maths background, that's convenient. If you've learned from Shirley and you've actually done a literal data science course, that is, of course, probably the best preparation you can do. So you can pivot in, but some of these are going to be easier than others. You're absolutely correct for most of those people asking that question. In terms of actually getting in and talking to an interviewer, having your resume look correct, there are a few key things you can do. Some of them we've already mentioned, Philip and I. Probably the most important one from my perspective is be able to talk about something in the space, ideally more things than one, but your ability to discuss it is probably the most important thing, especially if you don't have much actual work to show them. So if you've never worked in this space before, you've just picked up some of the skills and you kind of want to get your first foot in the door, your ability to talk about it is the most important thing, because that's what they're going to look for. They're going to look for someone who's got either a sharp mind or an enthusiasm for the work, or maybe just an existing understanding already, whatever it happens to be. If you can talk about an application of machine learning that interested you the most, that popped up in the news recently, or if there's a project that you've done and you can talk about it, that's really good. If there's a project your friend has done and you're just intimately familiar with it, you can talk about that too. Nothing's off limits. Go into an interview with the mindset of talking about something that you can discuss for a solid 10 minutes or so that you can make it clear to the interviewer that you have some understanding. You understand the key concepts behind what's been done, or you can show a bit of work you've done before. Just get that ball rolling, because that'll show you're enthusiastic about it. It'll show you're a bit of a self-starter. It'll also show that you've got the mental capacity to understand something and explain it to other people, which is a really good skill. That's probably my best piece of advice if you're coming out from outside of the discipline in order to get into it. I don't know if you've got anything to add, Philip.
Yeah, maybe get away from this idea that because you're studying computer science, you're going to be a programmer. Because you're studying data science, you're going to be a data scientist, right? Things change in life. So I started out in a machine translation team and have now worked on probabilistic models, Bayesian inference, causal inference. 5 to 10 years from now, chances are I'll be doing something else entirely, right? So, and also when you look at the courses that you're taking in your program, there are lots of overlaps between the different programs, right? So I think as long as you're doing something that's related to computers or related to math, I think you're fine, right? Because at least you have the basics to learn about whatever it is you want to learn about in the field of data science or machine learning. Coming from linguistics, I have to say that was quite a bit harder. As Ollie said, right, you can try to talk about these things. You can try to initiate conversations about these things. Generally, you don't necessarily have access to the right people because you don't have that network yet. And also you may just be lacking some of the fundamentals. And somebody in the chat already mentioned Coursera. Online courses have been a great resource for myself to just, get on board and shore up on the fundamentals that I wasn't so confident about.
Sure. That's great. And I do see some questions more so about, fixing your CV, who to speak to, things of that nature. Within Monash University, there's a group called Career Connect where they take workshops, they'll look at your resume and your cover letter and make sure that things are on track. So there are sessions that do run. We're also going to be running another choose your own adventure session similar to this, but with recruiters and what they look for in students. So keep an eye out. We'll send some information out to the students in relation to all this. As well, like I said, there's always people here that you can speak to, the course directors. There's, you can try your networking with LinkedIn, and sessions like this where we show you the ropes. But again, the ropes are always different for everyone. So this is a very broad chat, not something that is going to apply to every single person's situation, but we try and give you as much of the information as possible. I know it's quite daunting, especially if you're in your first year and not sure what the future holds. But listening to Ollie and Philip, they've definitely told us that life throws you curveballs, but it's how you deal with it, right? So yeah, again, I just want to thank everyone for their time. Philip, Ollie, Shuri, thank you for today. Everyone who's attended today, thank you. And we'll see you at the next session. Okay, have a great day.
Thanks, everyone.
Thanks for inviting us. See you. Bye.
Bye.